you go. I'm going to, this weekend, email out to you my Physics 12 work energy tutorials, and you're going to find about 80% of it is Physics 11, except every so often we'll do something on a ramp at an angle, or there's going to be some trig. You can ignore that. So if you see a question like that, don't freak out and think, give me all the time. No, but you'd be surprised, Sal, this unit and Physics 12 unit on work energy, really not much different, except occasionally I threw a ramp in at an angle, but the concepts are the same. So I don't have a tutorial made yet for Physics 11 work energy. It's going to be formed right now. Any questions you want me to go over? From now is the chance to ask. Really? Yes? Love to. I think I like them. Yes, I do. I like number 24. I like number 24. I like number 25. I like number 25. They're nice questions. Yep. What I'm going to do then is I'm going to copy and paste this, and I'm going to just change the numbers so you can still try the question on your own. By the way, how many marks is this worth? What does it say? This is actually from a Physics 12 provincial. Told you, I'm sneaking some Physics 12 in. Well, actually, I told you the units had a lot of overlap between grade 11 and grade 12. I'm going to make this a little bit smaller so I can fit this all on one screen. Here's what I'm going to say. Instead of a 250 kilogram roller coaster, I'm going to change the question. I'm going to make it 340 kilograms. Instead of 12, let's make it go a little faster. How fast? 15? And instead of 18 meters high, how high? How high? Let's go a little higher. I want the numbers still to be reasonable. Okay? And it says, what's the speed of the roller coaster at the bottom if, let's say, 9,500 joules of energy has been transformed into heat? So same question, different numbers. This is how I make half of these up in Physics 12 too, because the graphics are nice and I can't do graphics this good. Michael, is there a change in height?
Yes.
Is there a change in speed?
Yes.
Is there a yucky, curvy path? This is a job for conservation of energy, especially because the question didn't say how much work. If it said how much work, I'd go force times distance or area under a graph or change in potential plus change in kinetic. But this is wanting to find a speed or a height or speed in this case. So it's going to look like this. Tawny, that would be correct if this had said ignore friction or it was frictionless. But since this is talking about heat, I'll say, oh, and I guess whatever's extra current must have gone into heat. Then before I go further, I always ask, are any of these zero? Now, what I really mean, for kinetic energy to be zero, what must be the case? Has to be stopped. So is this roller coaster stopped anywhere? So none of the kinetic energies are zero. For potential energy to be zero, what must be the case? How high does it need to be? Zero. So where is it on the ground? In fact, if I'd been really clever, instead of using final and initial, I might have used A, and B, B, but initial is A, final is B. Okay. What's this question asking me to find? Tawny, what's this question asking me to find? Where is that going to be hidden in? I'm going to get that by itself. Specifically kinetic energy final, yes? Because the initial speed is 15. So I think on the next line I would say to myself, it's going to be the initial kinetic, my eyes aren't working, there we go, plus the initial potential, take away the heat, that equals that. Now let's actually introduce the equations. Kinetic is a half mv squared. Initial is going to be v initial. Potential is mgh, and it's initial. Heat, no equation, it's 9,500. By the way, heat is really force times distance where it's the force of friction. That's when we're a nice straight line. Here it's a curve, so I can't even use that. Anyways, they told me the heat. They said it's 9,500, 8,500 in the original question. That equals a half m v final squared. I think in this case, this is where my formula manipulation, I kind of wimp out. I'm going to actually crunch all of this together as a number, and then I'll divide by a half, divide by m square root. Okay? Because, I mean, I could get the v by itself, honestly, but it's a little yucky. If there was no heat there, the m's would cancel. I would do that. And then I'd probably multiply everything by 2 because it'd be worth getting rid of 2 of the halves. I could. Meh, not going to bother. It's going to be 0.5 times, what did I say 350 the mass was? The new mass? Did I say 350 or 340? 340, Mr. Dueck? What did I say? Oh, 15 squared plus 340 times 9.8 times 22 minus 9,500. That equals 0.5 times 350, 40, Mr. Dueck. I'll type the whole left hand into my calculator. 0.5 times 340 times 15 squared. I'm also hoping I end up with a positive answer because it's possible the numbers don't work. That's why when some of you were suggesting bigger stuff, I was a little reluctant to go there. Please be positive. Whew. So right now, I got 102,054 joules of kinetic energy. It's going to be really positive. This might be too big. 102,000. I don't want my roller coaster breaking the speed of sound or anything either. Equals 0.5 times 340 times v squared. Tawny, how would I get the v by itself? More specific. 0.5 and divide by 340, and then square root. Okay? V is going to be square root of 102,504. Did I copy that out right? 054. See how my brain was bugging me? All of a sudden, my brain said, you didn't copy it out right, Mr. Dueck. My brain works weird. Right, you guys noticed I copied it down wrong? My brain subconsciously did. It's that. Divide by 0.5 or times by 2. It's the same thing. Divide by 340. Here's hoping we're not going faster than the speed of sound. Divide by bracket 0.5 times 340. Whew, we're good. Square root 24.5. About 50 miles an hour. That's a pretty good roller coaster. Meters per second. Okay? So I like that question. I like that question. I like that question. Looking at this setup, I would also have no problem telling you how fast you were going at the bottom and saying how much must have been transformed into heat. In other words, if you knew that number there, I think I could ask you to find that, although it'd be easier to get it by itself on this line up here. I would have no problem asking you to find how high the hill was. In other words, giving you the same situation. If I told you how fast you're traveling at the bottom, I would have no problem saying, get the H initial by itself. Okay? All of those fair game, with or without heat.
Same with VI.
Sorry?
Same with VI.
Same with VI. I would have no problem saying, find how fast we must have been traveling at the top of the hill. It's complicated, but as long as you go systematically, it's not too bad. And if you haven't figured out, Kai, it's roller coasters! Sorry. If those of you that take Physics 12, you'll find we do lots of amusement park ride questions, because how could I not? Tawny, what was your other one?
It was 25, but I can figure that out.
Let's see. Are they the same question? I wonder. They're giving me an initial velocity, an initial height. They're telling me how much we lose to heat, Find V final. You know what? That is exactly the same question. Different numbers, different situation. Water slides, also a great example of conservation of energy. Change in height, change in speed, curvy path. Although with a water slide, you lose a lot more to friction. As any of you have gone water sliding all day may have found when your back had the little burny marks on it, right? But it was water slides. You've found that out the hard way before, right? No? Yeah. Do you guys remember there used to be a water slide right here in Pitt Meadows? Or is that... So you guys have forgotten that, eh? Oh, yeah. Right on the corner of Harris and Lougheed. Right beside the driving range. Someone built a big water slide there for a while, but it wasn't making any money. I taught in 1995 in Ecuador, in South America, for 3 weeks. And we were driving in the jungle hours from any civilization, in the middle of nowhere, bouncing on dirt roads, gravel roads that literally weren't even 1 lane wide. They were about 1/3 of a lane wide, branches ripping the sides of the van all the time, bouncing, and we come around, we bounce around a corner, and there's a huge water slide complex there, middle of nowhere. There's about 50 people on this huge water slide complex. Some investor had built it there, and in probably 30 years it'll be profitable because by then civilization in Ecuador will have gone that far out into the jungle. But it was just very surreal. What the? Okay. And then you drove a few more and back into the jungle and nothing again for hours. Still remember that. Is that all right? Any others? This could be the shortest tutorial on record, which is also fine. Yes, Anthony, that was a twitch or a question? Okay. Which review, which number? From which review? Okay. Sure. Mr. Dueck. Yes, Anthony. Shouldn't the answer right now be 0 if we're talking about Tiger Woods? Fair enough. Right? Isn't he going for back surgery now? Yeah. That Jack Nicklaus record is looking pretty much like a no-show. But good physics in golf. So here's what it's saying. From what vertical height would you have to drop a golf ball so that V final is 285? 285 what? Okay, first thing I would be saying is, okay, you're not going to get me there. V final, I'm just going to make a little note, 285. How do I go from kilometers per hour to meters per second? It's something to do with the 3.6. Divide? So first thing I'm going to go is 285 divided by 3.6. Okay. Really what we're saying is we want V final to be 79.16. I'll carry a few extra sig figs because I'm going to use this in my question. All right. So here's what it's saying. How high would you have to drop a ball from so that when it hits the ground, it's traveling 79.167 meters per second? Is there a change in height? Is there a change in speed? This is a job for conservation of energy. Potential initial, kinetic initial equals potential final plus kinetic final. Oh, wait. Does it say ignore friction? No heat. Are any of these 0? Again, for kinetic energy, what you're asking is, am I ever stopped? We talked about this near the beginning of the year, and I said, I'll expect you to remember. What does the word drop imply? What's 0? VI, which means KI initial, 0. Is the final 0? Well, after it hits the ground, but we're talking about right when it hits the ground, so no. Potential energy, when is it 0? When you're on the ground. Where? What? Oh. So really this question ends up being yeah? I noticed something, which is good because I was terrified for a second. What do you notice? Oh, thank goodness the mass is canceled because I have no idea how much a golf ball has a mass of, and it didn't tell me. What are we trying to find? Oh, get the h by itself, Anthony. G, yeah, I don't need to divide by m. Mass canceled. This is good. So I think I'm going to get this. The initial height is v final squared divided by, I'm going to go divided by 2g because there's a 1/2. That's the same as the 2 in the bottom. Okay. Squared divided by 2 times 9. You know what? Let's really impress you. Divided by 19.6 because that's what 2g is. I've done that one so often. Please tell me that's what the answer says. 320? Wow. Well, Tiger Woods in his prime was getting some serious power. Although he was not the longest driver, right? There's other people that generate even more club speed, usually with a lack of accuracy. In his prime, he was the best combination of hitting it long and far and keeping it on the fairway. Now, not so much. No, it's reality. His driving distance has gone way down. Go check out his numbers. Like in his late 20s and early 30s, I think he led the PGA in driving distance like 4 years in a row or 5 years average drive. Or no, sorry, driving distance combined with fairway accuracy. So fairway drives or whatever. He was like 4th in overall distance, but 2nd in accuracy or something. It was pretty good. Any golf fans here? Watch PGA golf at all? Right? Who hits it very, very far nowadays? My generation, it was John Daly, this fat, unathletic-looking guy who just clubbed the snot out of the thing and had about 2 years before and after substance abuse where he was playing great. Right? I think he's still one of the only. There was a hole in at the British Open. I think he's still one of the only ones to reach it in 2 by going over the clubhouse. Yeah. The year because he won a British Open, right? Out of nowhere, because I think he was a play-in. He wasn't even ranked, but he can play. Anyways, is that okay? Next. It's kind of a disjointed tutorial here. I'm all over the place. Okay, I'm going to pause. I'll give you folks about 10 more minutes, and then I'll pull us back in. You can ask me more questions if you want. I'll pause the video too. So from the conceptual review, we've talked about how number 5, the answer. By the way, what is the answer when you figure out the first part for number 5? How fast are you going when you hit the ground? No. Okay, let's do that too. I'm pretty sure, but let's crunch the numbers here. And then we'll do 8 and 9 since we have time. So it says all of these are 5 meters high. Okay, so that means the amount of potential energy is the same in each case. And since the final potential energy is 0, the amount of final kinetic energy is going to be the same in each case. So 5 meters. Here's what's really happening. Is there a change in height? Is there a change in speed? It's a job for conservation of energy. Although if you go P E initial plus K E initial equals P E final plus K E final, Darian, 0, 0. All of what it's really saying is, excuse me, what it's really saying is, Manny, all of your potential becomes all kinetic. What it's really saying is, woohoo! How would I get the V by itself? I would just times by 2, because that's the same thing, and then square root. I think as an equation, I can actually say V final equals 2GH initial square root. So if you go 2 times 9.8 times 5, it's the square root of 98. So it's going to be 9.9. You're going to be traveling 9.9 meters per second here. But understand it's the same physics for this ramp and for this ramp, because your final potential still 0, your initial kinetic still 0. So all of your initial potential turns into kinetic. It's going to be, has to be. If there was friction, that would make a difference, but they didn't mention friction, so I choose to ignore it. Otla, which was yours? Same handout, number what? Sorry?
8 and 9.
Okay. 8.
Is kind of the same thing.
Going to be almost the same thing, but it's worth reinforcing because it's one of the key concepts. It's why energy is so nice to analyze roller coasters with. You can't analyze roller coasters without it, but it's yucky. Shrink this down. A metal bead slides due to gravity. How fast is it traveling as it passes point B? You know what? What's the height? The same as the ramp question we just did. You know what? Since the mass is going to cancel again, and it's not talking about any, oh, it does say friction-free this time. You know what? It's going to be 9.9 meters per second. What about point D? Now, here's what's going to happen. Look up, look up, look up, look up. It's going to go here. Right there, it's 9.9. What's it going to do as it goes to C? Speed up. But what's it going to do when it goes back to D? Slow down by exactly the same amount that it sped up, which means, lo and behold, you see what I mean by you guys are really overcomplicating this? Oh, and it's going to keep going up. It's going to slow down. It's going to slow down. But now what's it going to do? By exactly the amount that it slowed down. Ah. Yep. It'd be going faster there. This is the beauty, Jeff, of energy being a scalar. It doesn't care about the path that you took to get there. All it wants to know is where did you start, where did you end? Number 9. I don't remember number 9. Rows of wind-powered generator. Rows of wind-powered generators are used in various windy locations. How many of you have ever been outside Palm Springs and seen there's about miles of the wind generators there? Do we have any big wind generators in BC? Where? Yeah, there's one on top of Grouse Mountain, right? Wind power, it's effective in some ways. The turbines, when they turn, they produce an awful lot of noise. They're not nice to live near. There's just no way around that, because all sound is turbulence in the air. The turbines, when they turn, create turbulence, and you can't get away. There's no such thing as a silent wind turbine. There isn't. So I don't know how much of the future that is, how much it isn't, but okay, we're looking for green alternatives. So here's the question then. We have rows of wind-powered generators. They're used in various windy locations. Let's think outside Palm Springs. Does the power generated affect the speed of the wind? Kyle nodded. Kyle's right. Did you not? You're right. Really? The energy's got to come from somewhere. Where does the energy to turn the wind power, these wind turbines, come from? The wind. So the wind loses energy. If the wind loses, how would wind lose energy? What would that actually look like in the physical world? The wind would what? Slow down. Has to. Law of there's no such thing as free energy. Energy's got to come from somewhere. So would locations behind the windmills be windier if they weren't there? Sure. I'll go with that. Sure. Now, probably once you're 10 meters behind the windmills, because I also suspect they're creating like vortexes and things, but you can't see because it's invisible in the atmosphere. I suspect once you're 10 or 15 meters behind, the air is kind of rushed in and become convoluted, and maybe you might not notice any significant difference standing in front and standing 50 meters behind the wind turbines. But I would imagine if you were standing 1 meter behind the wind turbines, you would notice a difference. How many of you have ever used a fan in the summer, an electric fan? Okay, so in front, air is coming out faster. Does that mean the air has to be speeding up, getting sucked in? Yeah. In fact, depending if you have an older model fan, one of those big rectangular ones, you can actually suck a paper onto the grill on the back and it'll stay there because it's sucking more air through and putting it out the front. So you can have some fun with that. Don't put your finger in the fan, though. Ow, heck. Honestly, if it's a plastic fan, feel free to put your finger in there. It'll just be owie, but it won't do any damage. Oh, shoot, I just recorded that for the internet. No, hang on. Don't put your, don't ever times infinity to the infinitive power plus infinity ever put your finger into an electric fan. We'll go back to record for posterity. Number 18, Tarzan. Once again, Kai, since this one has numbers, I'll change the numbers. Okay, 14 meters long, and he's starting 8 meters above the lowest point in his swing. Do I need to dulp, or can you visualize it? I think what we have is, I'll dulp. There's a platform. Here's Tarzan. So the rope is 14 meters long, but he's starting at a height of 8 meters. Is there a change in height? Is there a change in speed? You know what this is a job for, don't you? Okay, and we want to find V final right at that location as he swings down. So doesn't mention heat, so we're going to ignore heat. Are any of these 0? Is he ever stopped? Is he ever on the ground? Now, technically at the bottom, he's not on the ground, but again, Darian, one of the nice consequences of energy being a scalar is I can put the ground wherever I want to mathematically. I'm going to pretend that that's the ground right there. I'm going to pretend his final height is 0. By the way, I'm not going to use that 14, just like you're not going to use that 12. They threw that in there as what we call a distractor. Stick another number with meters, maybe kids, because some kids just try and memorize units and think, oh, I'll just put the right units in and it'll all work. Well, no, I want you to think more than that too. So we end up with this. Yes, Kai? Ooh, what do you notice? So not only would this work for Tarzan, but this would also work for Tantor the elephant. Fine. Wouldn't make it, as long as the vine could hold it, wouldn't make a difference. Okay. Oh, what do they want? V, I think times by 2, and then square root. Is that okay? You'll get a different answer here. You won't get the 9.9 unless I fluked and made up. No, I don't think you'll get the 9.9 again. But with those numbers, you should get 9.9. Okay? Yep. Tarzan swings, good physics. Rope swings, good physics. Curvy path. Again, analyzing that without a scalar approach, really tough. In fact, I'm pretty sure I can't think of a way to do it without using calculus. Because your angle is changing every split second, and that would be difficult. Your direction then is changing every split second. Could be done, but it'd be ugly. In fact, I have a feeling when you did it with calculus and you started simplifying this huge, horrendous equation, as I'm thinking about it, I think you'd end up with v finally equaling the square root of 2gh initial, and then you'd go, oh, you mean I could have got there with the scalar approach? Yeah, you had proved the scalar approach. Next. Don't do that, Juan. He was going to throw a phone or a calculator on the ground or something like that in frustration. That's bad. Yep.
Number 2 on the second paper, the second matrix calculation.
Number 2 on the second paper.
Yeah.
The concepts review or the other one?
Like the review we're currently on.
This one, okay. Number 2?
Yeah, I think matrix calculation.
I like, yeah, I like number 2. I like number 2. I like number 2. You have to go? Okay. Whoa, try that again. Again, we'll change the numbers. Hey, let's make this block 85 newtons. Let's push it 6.2 meters. That's important. Let's make the coefficient of friction 0.50. Well, Ben, work equals, and the fact that it says steady speed, I'm pretty sure that would imply a constant force, and I can use force times distance. I don't need to find the area under a graph, or I don't need to go change in potential plus change in kinetic. Oh, there is no change in kinetic because it's a steady speed. Okay. Which force, this is a time for a free body diagram. What are the forces acting on this block? Get the obvious one. Yes? This mysterious applied force. What else? Now, the work done, Ben, is going to be the work, is going to be the applied force times distance. I don't know the applied force. Oh, but look. I know another force that has to be the same size as the applied force because of what I underlined. Steady speed. What force has to be the same size as the applied force? Ooh. So the work done by the applied force, it turns out, is going to be the same as the work done by friction. That's a nice coincidence. And friction, I got me an equation for. Friction is what times what? Mu times the normal force. I don't know the normal force. Oh, but look. I know another force the same size as the... Are you starting to see why I spent so much time on free body diagrams? They really are a handy way to take something that otherwise is pretty ugly and make it not too bad. I think it's going to be mu times mg, and they gave me mg as 85. I don't need to multiply that by 9.8 because it is in newtons. They gave me mg times the distance. Oh, there it is. Mu 0.5 times 85 times 6.2 in my changed answer equation. Now, I would also, Ben, not have a problem. If I told you the applied force and I made friction less, you could find how much work I did with the applied force, how much I lost to friction by going work lost to friction. Heat is force times friction, force of friction times distance. And then I could say, okay, so find the network. How much went into speeding up this object? You'll notice there is no extra energy going into speeding up this object. All the work that you're doing is turning into heat here. How do I know? Steady speed. That energy, you are applying energy, force times distance. It's got to be going somewhere. Is it changing the height? No. Is it changing the speed? No. Ah, you're heating up the floor. Must be. Okay. Any others? Is that okay?
Yep.
23. Right before 24, which we already did. I bet you they're going to be similar, but let's see. Oh, no. Tricky. Nice. This An easier version of this to me is fair game. I've talked about the squared and how this would be a good physics 12 because we're combining a squared and something else. So I would say, okay. Oh. There's two things going on here. The mass and the speed. So the mass, we are dividing it by 3, and since kinetic energy is a half mv squared, if you divide the mass by 3, the kinetic energy is going to be divided by 3. Also, though, we're taking v and we're timesing it by 3. So if you put an extra 3 in there, you're going to end up with the kinetic energy being how many times bigger? So if we combine this, the speed's making it 9 times bigger, but making it lighter is making it 3 times weaker. If you go times by 9, divide by 3, what are you left with? 3 times bigger. Okay? This is why I said there's a trade-off when we make all this sports equipment slightly lighter, but we don't make it 1/3 as light. It's only slightly lighter, and you get way more bang for your buck with the club head speed, with the baseball bat speed, with the stick speed. Oh, and in the sticks we saw yesterday, you also get that flex of that, essentially like a rubber band slingshot effect as well for hockey sticks. Is that all right? Any others? Oh, yeah. Number 6, same review? I have no idea what you're saying. Could you speak louder for me, my friend?
I don't get what it's asking.
Probably a question. To what height above the bottom? You know what? It wants you to find H final. Okay? Now, you know what a pendulum bob is? Mass on a swing. And it's at the bottom. So what it's saying is if you know at the bottom, how high will it get? This is the Tarzan question sort of in reverse. We can try it. I'll change the numbers. I think I got time. Yeah, I got 90 seconds. You okay how I figured out that it's asking for a height? Okay, but you okay that it's asking for a height, and it tells me something about the bottom. I don't think they want me to find the height of 0. It's the other height, right? Is there a change in height? Change in speed? So far, so good there, Rob? Okay. Are any of these 0? I think since it wants to find the maximum height above that you're going to swing, at the top you come to a stop for a split second. Are any of these 0? You're starting out on the bottom. In physics, not in life. Okay. Although in your golf, never mind. By the way, all you need to say to me is, Mr. Dueck, how good is your golf game? And I say, okay, you know, the worst golfer on the team is the coach. So yeah, that'd be me. Is that okay? Hey. How to get the H by itself? How? Which mathematical operation? Really? It's adding to the H? Yeah, it's timesing to the H. Right. So, folks, I'm also around Friday afternoon.